Hi friends, this is Syed Reshma Sharif. In this video, we are going to discuss about an EMF equation of a transformer. Okay, so it's a simple problem based on EMF equation of a single phase transformer. Let's see the question. EMF equation of a transformer problem. A 50 kVA 2200 by 440 volts, 50 Hz single phase transformer has primary turns of 200. Determine flux in core, secondary turns, rated primary current, rated secondary current. Okay, so let's solve the problem. Solution. List the things given here. They have given a rating of a transformer. What they have given? Rating of a transformer. That is 50 kVA. Okay, and voltage ratio is given. Voltage ratio is given. That is 2200 by 440 volts. What else they have given? The n number of turns in primary side. N number of turns in primary side. N1 is equal to 200. So how we are going to use these given things in order to calculate flux in core, secondary turns, rated primary current, rated secondary current. Okay, so first we have to write an EMF equation of a transformer. What is the EMF equation of a transformer? E1 is equal to 4.445M into F into N1. This is the entire EMF equation of a transformer. Okay. Here 2200 is nothing but E1. E1 is equal to 2200. Okay. At a primary induced EMF. Then primary induced EMF 2200 is given. Let's substitute this E1 in this equation. 2200 is equal to 4.44 into 5M is a maximum flux induced in a core. So we have to calculate this one only. F into N1. Here frequency also given. That is 50 Hz. And n number of turns at a primary side they are also given. That is 200. So we solve, we will get 2200 is equal to 4.445M into frequency 50 Hz they have given into 200. That is 5M is equal to 2200 by 4.44 into 50 into 200, whereas 200 here is the number of turns. If we solve using a calculator, the maximum flux which is generated is equal to 0.0495 Weber. Okay. Next, what we have to calculate? Secondary turns. Secondary turns. Now we know the EMF ratio, that is E1 by E2 is nothing but N1 by N2. E1 by E2 is nothing but N1 by N2, where E1 by E2 is equal to N1 by N2, where E1 is given as 440, the ratio which has been given, whereas N1 means the number of turns at a primary side, 200 already given. We have to find N2, where N2 is equal to 200 into 440 by 2200. So we will get by calculating N2 is equal to 40. 40 turns will get at a secondary windings. Okay. Here N2 is at a secondary side, turns at a secondary side. Next, what we have to find? What we have to calculate? Rated primary current. Rated primary current. Rated primary current is also called as a full load current, that is I1FL, also called as full load current. Full load current. If I multiplied with a primary side voltage, volt ampere of a transformer, that is V1 I1 Fn, that is equal to Va. Because voltage only gives rise to a current, no. So we are multiplying this with V1. V1 is approximately equal to E1. If we neglect the primary side resistance and leakage reactance, then E1 I1 FL is equal to Va. So E1 is 2200, I1 FL is equal to 50 kVA. 50 kVA we are returning as this 50,000 VA. From this equation we will get I1 FL is equal to 50,000 by 2200. After we are calculating, therefore I1 FL is equal to 22.7273 amperes. Okay, this is a primary rated current. If we observe that kVA rating of a transformer from primary side as well as a secondary side, E2, I2, FL is equal to VA of a transformer. E2 is 440, that is 440, I2, FL, this is at the secondary side I am doing, okay, is equal to 50,000 I2 FL is equal to 50,000 by 440. I2 FL is equal to 113.6364 amperes. This is a required answer. See what we are finding here. Flux in a core. We already found flux in a core, that is 0.0495 Webers. Secondary turns here N2 is equal to 40. Rated primary current I1 F1 is equal to 22.7273 amperes, whereas rated secondary current, that is I2 F1 is equal to 113.6364. Okay, thank you for your watching. If you have any doubts regarding this, you can comment me on comment section.